Hey guys, welcome to Whiskey 3 Charlie Tango W3CT, your good old friend Jack. Back here once again in the old Jack Shack. So as the title and thumbnail I'm sure gave it away, we're talking about resonant versus random wire or non-resonant antennas. I want to give you my take on it because I build a lot of antennas, and I want to give you my feelings on it because if you're new to ham radio, or if you're just somebody just getting into HF and you're looking for antennas, I don't want you to make the wrong choices that I made. Not that they're absolutely wrong, but I want to make sure that I can help you, maybe guide you, save you probably a ton of money. And it's all going to be about what you want to do. So let's get started in this video right after this. Alright guys, obviously we are talking about resonant versus non-resonant antennas, okay, or random wires. Now if you're new to ham radio or somebody, and there's a million of these videos on YouTube, but this is my take. What I do when I make these videos, I don't watch anybody else's videos for any reference. And the reason I do this, I just want to give you my take on it and the way that I laid this out. Remembering that I am a teacher, okay? So I'm going to give you this is my ham radio journey, so this is my idea of how this is working, some of the mistakes I might have made, and I'm going to show you on my Nano VNA. If you don't have one of those, it's something you should pick up for about 50 or 60 bucks. I don't know, I think that's what they still cost. It's a very handy tool. Okay, so what we're talking about today is resonant and non-resonant antennas, are two classifications used for ham radio. Each has its advantages and considerations. Notice it doesn't say really disadvantage. You know, I don't look at any antennas having a disadvantage, even though people out there say, oh, it's a compromised antenna because of this or that. If it transmits and it receives, then it's worth having. It's a good antenna, right? It works perfectly fine. So compromised or non-compromised, like are you losing a dB here or a dB there? Heat, I've been finding heat in certain transformers does play a little bit of chaotic things there with the SWR, bouncing up and down a little bit, but other than that, and when you're generating heat, you're probably losing radiation off that antenna. So there's downsides, but as long as it transmits and receives, it's a good antenna in my book. Okay, resonant antennas are designed to operate at a specific frequency where they exhibit a purely resistive impedance and zero reactance, allowing for maximum current flow and effective radiation. So all that's saying is, just like I just told you, you're getting the maximum amount of power radiating out of that antenna. That's what you're shooting for, right? But there's trade-offs to that, and that's what I want to show you today with my Nano VNAs. So stick around here, what I'll do is I'm going to go ahead and put chapter markers in. This won't be a long video, though. A non-resonant antenna, on the other hand, do not rely on being a specific electrical length relative to the operating frequency. Now, if you go back a couple videos ago, I actually had all the random wire lengths in there, and I gave those to you. So go back and watch that video, and you can see those. They're pretty standard. They can operate over a wide range of frequencies and often used in multi-band applications without the need for complex tuning mechanisms. I don't know who wrote this or who put that in there, but you are going to need an antenna tuner. All right. So if you have a radio, let's say for instance my QMX. My QMX radio, I only use it with a end-fed half-wave antenna with a 49-to-1 transformer because I know that antenna is resonant on certain frequencies. All right, so it does 10, 15, 20, and 40. So I know it will work well on there, and I don't have a tuner on that radio. Now the G90, I hook it to anything, and I can hit the tune button. I'm pretty much going to tune it up. So that helps a lot. Some hams prefer resonant antennas for their simplicity and efficiency. Others find that non-resonant antennas offer greater flexibility and convenience. Now, everybody knows, and this morning I actually was out doing a pod activation early this morning, And I used two different antennas. I used my $9 end-fed half-wave that I recently built on this channel. You guys seen that. Worked extremely well. And I used that with the G90. But then I moved to another park, and I decided at that park I was going to use my Wolf River coil, which it has that coil so it adjusts to a resonant frequency. Okay? So now there's a downside to that because you have to have something like a Nano VNA or an antenna analyzer to adjust that thing up and down the collar to tune it, right? Where the end-fed random wire, I just hit the tune button and I go. So that gives me more flexibility, because then with the Wolf River coil I decided to go from 40 meters to 20 meters. I had to get out of the car, go back around, readjust the coupler. You should check the tune, which I checked it with the G90, made sure it was matched, and then I was able to change frequencies. With a random wire, you just simply hit a button on your tuner and you tune up. And again, I'm not doing a video on this because I don't know all the parts about it, where people say, you know, you're not really tuning the antenna, you're just making the radio happy to believe that the antenna is tuned. So you are losing some power between those two. But other than that, it works extremely well. So, all right. Okay. And I just highlighted a couple things here. This is exactly how I teach in school. In summary, the choice between resonant and non-resonant antennas depends on specific needs of you, the operator, including desired frequency range, available space, portability requirements, and personal preference regarding setup complexity and efficiency trade-offs. So again, resonant antennas are very efficient. Okay, they have a 50 ohm load. They're very efficient and they work very, very well. When doesn't a resonant antenna have a impedance of 50 ohms? When is that? Well, it's the most popular antenna on the market, the end-fed half-wave. The end-fed half-wave antenna is fed, mine is fed with a 49-to-1 transformer, and I believe our club made a 36-to-1 transformer. They said it's extremely efficient, works really well. I still have to build one of those, actually. I wasn't in the club at that time when they did that build, or I would have had one of those on the roof. Anyway, so I just wanted to give you the backstory about the two different ones. Okay, again, there's a lot of information on YouTube about this. Look it up. Watch some other people. I just watched one guy. What's his name? David Kessler with Ask Dave. He's really good. Watch Walt. Walt will tell you a lot of stuff. Walt uses more random wire antennas than he does resonant antennas. He does use a few because he does build some vertical dipoles and such. But most of his stuff seems to be random wires, like me. I really like random wires. So why? Why do I like random wires? I pretty much went over that. When I go out, I can throw it up in a tree. I can change frequencies. My favorite POTA frequencies at the moment is 20 meters, 30 meters, and 40 meters. I get really good results on those bands, and I tend to stick around those bands. Again, if you use the Wolf River coil, you have to get out and retune it each time, or if I'd have a dipole up in there, say I put a 20-meter dipole up, it would pretty much be for 20 meters. So, all right, what I did now was I brought up a couple of, let's see here, I think this is it, yeah. So, on DX Engineering, I actually bought one of these before I started building my own unknowns. Building an unknown is so easy. Go back and watch some of my videos. It's a piece of cake to build an unknown. You know, get yourself some wire. You can build tons of these things. But if you're not into building, that's okay. I understand. Because when I started out, I was not. So I bought this, the LDG 9-to-1 unknown, for $30. All right? And I believe, well, they have some other things in here too, some other different types of balance and chokes or unknowns. I don't know. Yeah, that looks... Anyway. So they have a bunch of other stuff in here. They also have stuff in here like Moonraker end-fed long-wave antennas. You know, you can buy this and put this up. I believe this is, and this is ridiculous. And DX Engineering, I love you guys. I buy 90% of my stuff from DX Engineering, but come on. Look, 9-to-1 unknown. with 136.81 feet of wire. Okay, so it's pretty much random wire. $190. Don't do that. Don't do that. Look, if you want to do that, seriously, buy this for $30 and buy yourself a 100-foot of speaker wire off of Amazon for, I think I just bought another roll last night for $12. So you can have this whole antenna here. They want $190 for that antenna. You can have the whole antenna for $40. See what I'm getting at? I'm trying to help you out there as a ham operator to not make the mistakes I made. So when I got back into ham radio years ago, I was into ham radio. I had my tower up. I had a Cubical Quad. If you don't know what that is, look it up. It's a great antenna. And it worked extremely well. Very efficient. It was 5 bands. So fast forward 25 years later now, just getting back into ham radio. I wasn't sure what I wanted to do. Before I was a buy the antenna guy. I never built anything before. So that's a mistake I made now, because when I looked at buying, I thought, okay, I bought the Icom 7300. I bought a power supply off of DX Engineering. I was going through here looking at antennas. I was like, what kind of antenna do I buy? Then I just happened to stumble across a YouTube video for the company called MyAntennas.com. I thought, wow, they're saying this company here is, greater than bread and butter, man. This is the best company out there to buy an antenna from. They're highly efficiency, well built, and they work extremely well. And they do. It's a very, very good, high quality product. So don't get me wrong. Look at these prices. This kind of upsets me though. They're 30% discounted right now. Okay? Check that out. I paid $225 for mine. This is the exact one I bought right here. End-fed half-wave, 40 through 10. Okay? And I bought the pole installation. We're going to take a look at it right now here on the video. You can see I took the camera out, did a little bit of shot of it there to show you the antenna itself up on the pole. And, yeah, so I bought this antenna thinking, that's all I need, right? 40 through 10, not thinking, because years ago I had an MFJ antenna tuner where you would turn the knobs back and forth and adjust the tune. Well, now I have a built-in tuner. I thought, well, I could just tune this to any band. It's going to work really, really well. No, that's not the case, okay? It's cut for specific bands. Now, let's go to the Nano VNA and have a look, okay? So, I have my Nano VNA set up here. Actually, I want to move my big head back over to the corner over here. How about that? Okay. I have my Nano VNA set up here, and we can see where these dips are. Remember I told you that antenna is 10 through 40. So what you're seeing here is this at the bottom of this band over here on the far left. You can see where my mouse is. And look up here. It's 7 megahertz. Okay? 40 meter band is right there. 40 meter band is there. So if you look at this and plot this out, I'm trying to get this down a little bit more. There we go. So if I plot this out over here, the next point, the lowest point, because this bottom line here is your SWR. So you see there, at 7 megahertz, I got a 1.8 SWR coming directly off my Nano VNA. So this is live right now. Okay, this is absolutely live. Next, I went down and I said, okay, what's my next frequency? 13.6, I got a 1.67. You don't transmit on 13.6. It's out of band. So I'm going to move my arrow key up here. And the closest I can get right now is 14.130. So now I'm in the 20 meter band. I got a 1.8 SWR. Okay. So what I thought was, I got my band sheet out here. Everybody should have one of these printed out, by the way. Have this by your radio. I got my band sheet out, and I thought, okay, well, maybe, just maybe, I could possibly go to the 30 meter band. Right? Because I want to go 30 meters. So I just moved my pointer here go up, 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 up. Okay, the closest I get right now is 10.220. Okay, so 30 meter band. But look at the SWR, 7.45. My radio won't even tune at 7.45. I guess I could put it in emergency over tune, and I won't do that to the ICOM. I don't want to blow my radio up. I don't need to bother with that. I have other solutions. So 30 meter band is out. Okay, I got 40, and we've seen I got 20. So I got 40 and 20. Try and get me some more light here. So 40 and 20. So I said, okay, 18 megahertz. Let's go to 17 meter band. Okay, so that was 14 was right about there. So let's go looking for 18 up our scale here. $18. Okay. I surely hope this is capturing everything. Guess I should check that beforehand. So 18, it showed me 5.67 SWR. Again, unusable. So that's not any good. So the next band we're going to go to is 21. Okay, so 15 meters. If you go back down into the dip here, let's go up. 21.030, which is where I would be for CW. 1.7. Okay, well that's usable. Remember, this is a 4-band antenna. 10, 15, 20, and 40. That's it. 4 bands. $225 for 4 bands. Okay. Now, is it highly efficient? Is it more efficient than a long wire? So they say that's supposed to be more efficient. It still does have a transformer, though. It's not a resonant antenna, right? Because I could feed that then just with one of those little banana plugs. This is fed with a 49-to-1 transformer. So there's still some inductance going on in that transformer, some heat being generated. Marginal, because I mean it is made for 1 kilowatt, so, and I'm only throwing 80 watts through it. Alright, so that is, where was I at here? We was at 15 meters. So let's go to 24. So 24 would be 12 meters. Where are we at 24? So we're at a 4.46. Okay, SWR. Again, unusable. And then we're going to go over. We're going to go down to 10 meters. So there's 28,160, and we're at 1.28. Okay, so it's best on 10 meters. It just rocks on 10. Too bad 10 meters wasn't open, because it would be fine. All right, so why Jack? We can go back to the other camera here and wrap this up and tell you a little bit about my thoughts, where I went wrong, and how you can save money and do things the proper way. Okay, let's go back over to the other camera. Okay, guys, so anyway, the reason I wanted to do this video was just, again, to try to help some people out there. I am not by any means a Walt. I am not a Dave Kessler, this guy, Ask Augie. These guys have been around ham radio longer, or, well, maybe not longer than I have, but they've been around antennas and building, and they understand that part of it probably way more than I do. All I'm trying to do here is trying to take the new ham. I watched the new ham this morning. He just started a YouTube channel. I'm sorry I forgot your name, but I will post it here so you can go check his channel out. He's brand new at ham radio, just got his general license, and he was trying to figure out, he needed an antenna, right? I want you to be able to get the most bang for your buck, right? When you get that new general license, the last thing you want to be is stuck to 4 bands. Now, why did I do this? Because when I was rebuying everything, I didn't know any better, right? Another thing I could tell you, and I told some hams this morning about it, was buy this book right here. I know you can also buy good old Salty Walt's book, but this book is really good. Portable wire antennas. Start building your own stuff, guys. Don't go, and like I said, DX Engineering, I love you, but $190 for a random wire antenna, way too much money when you can build it yourself for like 30 or, no, 40 bucks. $40. Buy yourself a 100 foot of speaker wire and a 9-to-1 none that was my first antenna on the house, because after I ordered the MyAntenna and it was, in the process of being built and shipped, I I found Walt's channel. I bought a 9-to-1, hung it out my window, and I had an antenna running before I ever got that on the house. And it worked. I was able to make contacts. So again, it's all about what you want to do. It's up to you. It's your radio. There's no right way. There's no wrong way. There's only the transmit way and the receive way. Play around, though. Have a lot of fun with antennas. You can get one up there. MyAntenna's been on my roof now since I got back into ham radio, which was March of 2024, I believe that was. Like a year ago, right? So I got back into radio, and it's been up there, and it's been working. So, but thanks for watching. I hope this helps you out. Choose what's right for you. I can't be the one. And I look at a lot of different groups, and people say, "What groups do you watch, Jack?" Most of the groups I watch is Instagram. I don't really watch a whole lot of Facebook stuff anymore. But, people always have that question, which antenna should I buy? That to me is like saying, what kind of jogging shoes should you wear? Or what kind of jogging shoes should I wear? It's a very personal choice. We can guide you and get you to the point where you're going to transmit and receive. But it's very personal to you, what you want to do. So some guys like verticals. Some guys like hex beams. Some guys like Yagis. Some guys like, everything has its place in ham radio. It depends on what you want to spend, but don't overspend. Be careful what I just showed you. Don't overspend. You could build these long wire antennas for dirt cheap, man. So there you have it. Guys, thank you for watching. I hope this helps you, and if it did, give it a big thumbs up. Smash that subscribe button. I'd love to have you back in here and stick around here with me. And until next time, this is Whiskey 3 Charlie Tango, W3CT, your good old friend Jack. This is my ham radio journey. And guys, I will talk to you and hope to catch you on the airways. 73s, and bye for now.